In this video, we'll learn how to evaluate limits as x approaches infinity. The x term with the highest degree is going to have the greatest impact on the limit. The location of this, whether it's in the numerator or the denominator, is going to determine if your limit approaches infinity, is 0, or some other answer. Let's look at a rather simple example to see why this happens. Imagine we want to find the limit as x approaches infinity of x squared plus 3 divided by x minus 5. Let's look at the term with the greatest degree in both the numerator and the denominator and factor that out. Factoring in x squared on the top would give me 1 x squared times, in parentheses, 1 plus 3 over x squared, and in the bottom, x times 1 minus 5 over x. Now, the reason I did this is to see the impact that's going to happen when x approaches infinity. Let's look at this term. 3 divided by x squared when x approaches infinity. Remember, when the denominator gets larger and larger, this is going to approach 0. The same thing's going to happen here. So by factoring out the largest degree, we can see that a lot of our terms cancel out. Also, we can simplify. This would give us the limit as x approaches infinity of x squared divided by x. Well, that would just be x. And then we had 1 plus 3 over x squared and 1 minus 5 over x. As we said before, these terms are going to go to 0. So what we would have left would be x times 1 divided by 1. That means our limit is infinity. Let's look at another example. The limit as x approaches infinity of 5x cubed plus 4x minus 8 all over 2x cubed plus 5x squared minus x. Again, we're going to factor out the x of the highest degree in both the numerator and the denominator. In this case, that's x cubed for both of them. Factoring x cubed out of the top left me with 5 plus 4 over x squared minus 8 over x cubed. And in the bottom, I again factored out x cubed, and I had 2 plus 5 over x minus 1 over x squared. Now we need to simplify. When we simplified, the x cubed canceled out in both the top and the bottom. So I was left with just the inside of each of those fractions. Now we're going to see, well, what's going to happen to them as x approaches infinity. Again, each of these has an x in the bottom of a fraction. So as x approaches infinity, 4 divided by infinity and 8 divided by infinity would both be 0. Same thing's going to happen down there. Notice that we have constants. Those aren't going to be canceled out because as it approaches infinity, that has no impact on it. So here, as we approach infinity, our answer is 5/2. The concept is the same even if we're approaching negative infinity. Again, we start by factoring out the x of the highest degree. So I would have the limit as x approaches negative infinity of x squared times the quantity 4 plus 2 over x, all divided by x cubed times the quantity 3 minus 8 over x squared. Again, look at those individual fractions and think about what's going to happen as x approaches negative infinity. Again, that would approach 0. So that term would become 0. This term would become 0. And we should simplify down as well. X squared over x would leave an x on the bottom. We would say that would be 4 plus 0. And on the bottom, we would have 3 minus 0. Okay, so we still have our x. As x approaches infinity, at the bottom, or negative infinity, we're essentially going to have 4 divided by negative infinity. Okay, so we're dividing by a really, really large absolute value. Again, that's going to approach 0. So even though we have some constants left in there, since we have the highest degree on the bottom, this would be 4 over a large number, means it's going to approach 0. Let's look back at the problem and see if we can find a pattern. In this case, if you compare the initial degree, notice that the higher degree was in the denominator, and our limit approached 0. In our first problem, our higher degree was in the numerator, and our limit approached infinity. In our second problem, the degrees were equal between the numerator and the denominator. Our limit approached a constant, which was actually the coefficient of those powers with the highest degree.